It's that time of year once again where fans start sprouting all over your town's sidewalks and roadsides. I'm talking about the types of fans which have been pulled out of storage only to have their owners finding them not functioning anymore. So your friends and neighbors simply buy new fans and put the defective ones by the roadside. The thing is, they're usually relatively easy to fix. The problem, more often than not, is a burnt out thermal fuse. I've talked about thermal fuses on my channel in the past. Thermal fuses. It's time we had a talk about thermal fuses.
Shut up! Just shut up. You had me at thermal. You had me at thermal.
And it seems to me that these small safety components are ever increasingly defective. But what do thermal fuses do? If an appliance starts overheating, it could be because of restricted airflow, a seized up or overloaded motor, or some other malfunctioning component which is drawing excessive amperage, which in turn generates too much localized heat, the thermal fuse shuts off power to the appliance before it bursts into flame. And not burning down your house is a good thing. A very good thing. Decades ago, some appliances had built-in reset switches, and some still do. Usually on the bottom, usually neatly marked. You'd press the switch and your appliance was functioning. You'd just be careful not to overload the mixer again, or whatever you were using. But what's fun with that? You still had the same appliance without the need to buy a new one, therefore depriving the manufacturer of important revenue. It's called the replacement cycle, younger cousin of planned obsolescence. If home building was left entirely in the hands of manufacturing corporations, your home's electrical system would have non-resettable fuses.
Hey, hun! We'll need to order a new house. This one's got a blown electrical.
You think I'm exaggerating? Have you tried maintaining any of your fancy new cars? The thermal cutoff is essential, but no more reset switches. The standard these past few decades has been non-resettable thermal fuses. So consumers got smart and they'd open up their appliances, easily find and swap out the blown fuse for one with the same rating because they're inexpensive and most recently very available, especially online. Some manufacturers started mounting their thermal fuses, which had been relatively easy to get to, deeper inside the appliances, like inside the motor windings, and sometimes more than one thermal fuse within the same winding. If you're thinking manufacturers wouldn't go through all this trouble to keep you from fixing your own stuff, then you haven't seen the methods and the range of fasteners and safety screws which are used to keep you out of your appliances. Some screws need drivers so specialized for screws set so deep down narrow wells that it's almost impossible to release them. And those metallic stickers laid over hidden screw holes with the no user serviceable parts within, or warranty void if sticker removed, all to protect you, you think? That sticker really says, if this is broken, don't bother, just buy a new one. And here's a phone number. All this having been said, I'll have to re-edit this video if the problem with this fan isn't the thermal fuse. Hey, Future Bob here. It would seem I could do some editing, maybe even delete this entire video and never publish it. But I'm letting past Bob dig us a hole. But I'm betting on the fuse, a deep hole. Viewers of this channel have heard me talk extensively of my work with repair cafes, and I absolutely love being a volunteer at their events. When an appliance like a popcorn machine, a hot plate, a toaster oven, or a fan comes in, we'll sometimes take bets on the thermal fuse. And in this case, I'm betting on the fuse again. Bottomless. There's a fairly standard way of testing and repairing this type of appliance. First and foremost, make sure you've got a reliable power source. If it's batteries, make sure they're good or charged up. If it's house power, make sure you've got power. Attempt to start up the appliance. You'd be surprised how an appliance, once it's been unplugged or has had time to cool off, can almost magically function again. If that's not the case, unplug it because now the fun part starts. Opening up the defective appliance. What am I forgetting? Yes, one of those handy magnetized trays to keep screws and small parts from rolling all over the place and falling off my workbench. There's always the possibility that power isn't getting to the appliance because of a break in the power cord, and that's where you use your multimeter to test continuity between the plug and as far up where the cable feeds into the appliance. Or the problem could be this series of buttons, and I'm betting on the thermal fuse. Remember? I remember. Remove the screen and the propeller. The plastic nut holding it in place unscrews clockwise, but the nut holding the back screen unscrews counterclockwise. 4 Phillips screws hold the front housing cover in place. Then you'll need a longer Phillips shaft to remove a screw holding that control knob in place. 1 short Phillips at the back, and the casing can be removed completely. There's a startup capacitor attached to the side of the motor. Oh, look! Another component which can sometimes fail. But the inscription has been almost completely scraped off. From the looks of it, it looks like somebody used a grinder to possibly remove the specks, but the inscription is still mostly legible. There's nothing inside the plastic housing which would indicate that the capacitor scraped up against something. That plastic gearbox screwed onto the back of the motor housing is what makes your fan swivel. 3 screws there, and another one holds the capacitor in place. Then the swivel's gearbox can be pulled off the shaft. And that's when I realized the shaft is really seized up. Maybe this is what caused the motor to overheat? To open up the motor housing, I need to remove 4 more bolts and nuts. The back of the housing slides off relatively easily, but the front-facing portion of the rotor has a slotted spring pin through it. With the rotor removed, I can take a closer look at the armature, and I can't see the thermal fuse. Maybe this is when I start to realize
I was wrong.
But I do need to loosen up the rotor and degunk both ends of the shaft and the flanges. Not bearings, just highly polished tubes which hold the rotor centered. I can polish both ends of the shaft with light sandpaper, and then the flanges with that same sandpaper wrapped around the driver bit. At this point, I was thinking maybe the seized shaft was the fan's only problem, and maybe now it would work. Also, take pictures to help with reassembly. Maybe I could have mentioned that if you're following along with your own fan laid out in pieces on your kitchen table. Reassembled, I can hear the hum of the motor, which would mean it's not the thermal fuse after all. A blown fuse cuts power to the unit completely. Upon giving the rotor a little spinning nudge, it starts turning.
Okay.
So, if it's not the thermal fuse, what can be causing this fan to fail? This, the start capacitor, which gives single-phase electric motors like this the initial push.
Don't push me.
It needs to get going. Think of the start capacitor as this fan's morning coffee.
'Cause I am close to the edge.
A word of warning. In a sense, capacitors are like rechargeable batteries. Though they charge up quickly, then discharge almost instantaneously. And they keep their charge for a time even when the appliance is unplugged. Voltages can range from a few to thousands of volts in big industrial capacitors. But if you're not absolutely certain of what you're getting into, don't mess around with these. For example, this one here might be packing upwards of 200 volts. I ordered a capacitor discharge device, but from what I've seen, it's possible to make a simple discharge device using alligator clips and a resistor. But I really want to see how many volts are potentially in this capacitor. A while ago, I took the probes from an old multimeter and I ground down the tips to very, very fine points so that I can poke through the plastic, the insulation of wires, without having to take a component out of the circuit. This way I can test it. Nothing. No charge at all. This replacement capacitor is identical, which is a good thing. I've slipped heat shrink tubing over the wires before soldering in the new capacitor. Remember to flux and tin your wires before soldering them together. If you've got another method, please feel free to share. If you've got another way of pronouncing solder and would like to let me know how the L in solder is silent in your part of the world, well, yeah, I've been told already. Eventually, I'll run out of this ancient roll of fluxed solder. That's Archer, as in Archer from the Radio Shack era. The wires having been joined, slip the heat shrink tubes and outfit those connections as if they were wearing yoga pants. Now reassemble the motor. You saw how I took it apart? Repeat the process in reverse. Though not completely assembled, I'm really looking forward to seeing this fan work. And it does. All right. All for this $7 start capacitor. I'd like to take a moment to thank you and all my fans. Thank you all. Good night and stay cool.